Most people think space travel fails because we don't have fast enough rockets. But that's not the real problem. According to Brian Cox, the universe itself is the obstacle. Even if we mastered perfect engines, even if nothing ever broke, the laws of space and time quietly guarantee something disturbing. No human will ever cross the stars and come back within a single lifetime. And the reason has nothing to do with technology. Welcome to Simulation Hypothesis. This is where we slow down and question the stories we've been told about space, time, and our future in the universe. We don't chase hype or sci-fi fantasies here. We follow the science, the limits, and the uncomfortable truths real physicists talk about when the cameras are off. If you're new, stick around. Subscribe if this kind of thinking pulls you in, and let's figure out together what humanity can and can't actually do out there. When people imagine humanity spreading across the stars, they usually picture a problem waiting to be solved. Faster engines, better fuel, bigger ships. The assumption is simple: space travel is hard now, but give science enough time and we'll eventually brute force our way through it. That belief feels natural because it's how progress has always worked on Earth. We once thought crossing oceans was impossible. Then we built better ships. We once thought flight was absurd. Then we built engines and wings. So it feels obvious that interstellar travel is just the same story, scaled up. But according to Brian Cox, that intuition breaks down the moment you stop thinking like an engineer and start thinking like the universe. Because the real barrier to traveling through space in one lifetime isn't technology, it's time itself. Every human life is measured in decades. The universe is measured in billions of years, and that mismatch isn't something you can engineer your way around. Start with the nearest meaningful destination outside our solar system. Proxima Centauri, the closest star to the Sun, sits a little over 4 light-years away. That doesn't sound like much until you remember what a light-year actually is. It's not a unit of time. It's a unit of distance, how far light travels in a year, moving at roughly 300,000 kilometers every second. Light doesn't slow down. It doesn't rest. It doesn't stop to refuel. And even at that speed, the journey takes more than 4 years. Now imagine a spacecraft carrying humans. It doesn't move at light speed. It can't. Einstein's theory of special relativity forbids anything with mass from reaching that limit. As you push closer and closer to the speed of light, the energy required doesn't just increase, it diverges toward infinity. No engine, no matter how advanced, escapes that math. You can get close, but close still isn't enough. Suppose, generously, you build a spacecraft that reaches 10% of the speed of light. That would be an achievement so extreme it would redefine civilization. At that speed, the journey to Proxima Centauri still takes over 40 years, one way. Not counting acceleration, deceleration, detours, or failures. A child who boards that ship would arrive as an old person, and that's the closest star. The Milky Way itself is about 100,000 light-years across. Even light needs 100 millennia to cross it. No human lifespan, no biological workaround, no incremental improvement bridges that gap. Brian Cox often emphasizes that space isn't just big, it's actively hostile to our sense of scale. On Earth, distance feels conquerable because time feels forgiving. You can always add another day, another year, but cosmic distances don't just stretch space. They stretch causality. They separate events so completely that travel stops being a meaningful word. Then there's time dilation, the effect people often misunderstand as a loophole. According to relativity, the faster you move, the slower time passes for you relative to the rest of the universe. In principle, if you traveled at 99.999% the speed of light, you could cross vast distances while only aging a few years. But this isn't a cheat code. It comes with consequences that make the idea meaningless for human exploration. From Earth's perspective, decades or centuries still pass. Civilizations change, languages die, ecosystems collapse or evolve. Even if the traveler survives, they return to a world that no longer exists. Cox points out that this isn't just inconvenient, it breaks the social fabric that makes exploration human in the first place. Exploration only matters if knowledge returns, if journeys connect generations. Time dilation turns space travel into exile. Energy is the next wall. To accelerate a spacecraft to relativistic speeds requires energy on a scale comparable to stellar output. Even nuclear fusion, often imagined as the ultimate fuel, falls short. The mass of fuel required becomes comparable to the mass of the ship itself, which then requires even more fuel, creating a vicious spiral. This is formalized in the rocket equation, a piece of physics so unforgiving that it effectively bans traditional propulsion from interstellar dreams. This is why Cox and many other physicists speak bluntly about one-lifetime space travel as a category error. The universe isn't waiting for us to get clever. It's already decided the terms. Some people turn to science fiction solutions. Warp drives, wormholes, space-time shortcuts. These ideas aren't nonsense. They emerge mathematically from Einstein's equations. But mathematics alone doesn't make something physically real. Warp drives require negative energy densities we've never observed. Wormholes, if they exist at all, would be unstable, microscopic, and lethal. There is no experimental evidence that spacetime can be manipulated in the way fiction demands. Cox's position is careful but firm. Until there's evidence, not speculation, not equations, but observations, these ideas belong to imagination, not planning. Even robotic exploration struggles under the same constraints. Voyager 1, the fastest object humans have ever built, has been traveling for nearly half a century and has barely begun to leave the sun's neighborhood. At its speed, reaching another star would take tens of thousands of years. Robots don't die of old age, but civilizations do. Funding does. Institutions collapse. Meaning evaporates. And that leads to the most uncomfortable implication of all. Human evolution did not prepare us for this universe. Our biology evolved to survive on a single planet, under a single star, within a narrow window of temperatures and pressures. Every second in space tries to kill us: radiation, vacuum, micro-impacts, isolation. Even Mars, a planet we romanticize as nearby, presents challenges so severe that permanent habitation remains speculative. Cox often reminds audiences that we underestimate how fragile complex systems are. Life support systems, ecosystems, psychology, these don't scale indefinitely. A spacecraft isn't just a machine, it's a moving biosphere. And biospheres don't like being rushed, frozen, irradiated, or cut off from evolution. Generation ships are sometimes proposed as a workaround, massive vessels where multiple generations live and die en route. But that raises questions physics doesn't answer. What culture survives? What governance holds? What happens when descendants refuse to continue a mission they never chose? That isn't engineering. That's sociology under cosmic pressure. From a purely physical standpoint, Cox's conclusion is stark. The universe allows travel. It does not allow convenience. It allows motion. It does not allow return. This is why he often reframes humanity's future not as a migration story, but as a stewardship story. If interstellar travel within a lifetime is impossible, then the most important place in the universe is the one we already occupy. Earth isn't a launch pad. It's a lifeboat. That doesn't mean exploration ends. Telescopes extend our senses across billions of light years. Probes extend our reach. Physics extends our understanding. But the dream of personally crossing the stars, of leaving Earth and coming back changed but intact, belongs to myth, not destiny. In a way, this realization is more humbling than discouraging. It forces a shift in perspective. We are not meant to roam the universe like nomads. We are meant to understand it from where we stand. And that may be the deepest lesson Brian Cox keeps returning to. The universe didn't fail us by being too large. It revealed what we are, a brief, conscious pattern in a vast, indifferent structure, precious not because we can go everywhere, but because we can. We get one lifetime, one planet, one thin moment in cosmic history where atoms arrange themselves into beings capable of asking these questions at all. And the universe, silently and without malice, makes sure we don't forget it.